let's say we're starting from the beginning of a project. I don't know if we can say they have no data at all, but let's say they have a reasonable amount of data and they have a reasonable case. What is kind of the timeline or process to go through to go from beginning to end? Or usability, I would say, production environment.
I would start with talking to people and collecting their visions. It's good to include people who know the process well, people from operations. I would collect data. I would inspect the site. I would analyze the previous experience of automation efforts that were done to have a clear understanding of the task. Then we come up with the preliminary architecture, how we would solve this problem and what would be the hardware, what would be the initial idea of the pipeline, of the model pipeline. And then you understand what would be the riskiest assumption. So what can kill the project? Understanding it early on, and you focus on that assumption and you take it as a hypothesis and you test it. So fail fast, Silicon Valley approach. For startups it works perfectly with AI projects.
Sure. So like what does that mean from like the mathematics side? Like what assumptions are you making or needing to make?
It can be a change in product, for example. For the customer, it may, for example, sometimes there are things that people do not know about. For example, as we worked with some packages, they just don't know that they have different designs of packaging. It looks very similar, but it comes from different suppliers, the packaging itself. There are small nuances in the packaging that are, for a person, for a human, it looks the same. For the model, it's different.
Gotcha. So like you're going to train the model, have all these images on one style, and then they introduce a new style, and now the model has no place to go in this like new set of data that has been introduced.
Not just a new style, but a different lot of coming from a different supplier that uses a bit different equipment or a bit different designs.
Gotcha.
So this kind of thing, variability is, look for variability, I would say. That these are the main risks. Variability can be in the product, in the manufacturing process, in the business process. It can be in your equipment, in the environment. So look what can change.
Which all sounds like a very similar type of process to how I would work for deploying a control system. So
absolutely, it's the same.
So now we have like it set up and we can start to develop the model and training set and everything. Like what does that look like as far as implementation?
You collect the data, you create a test data set, you establish the metrics that would define success, and usually you make a proof of concept, a POC. It can be done in the lab environment or in the production environment, depending how you approach the problem. And the POC, the proof of concept, is showing if the major hypothesis is true, if you can solve the problem in general without going much into detail. So POC is the first stage.
Gotcha. So you just have like a general package that is going to be detected as good or bad, and you don't have...
How well does your pipeline and your model work in conditions where not all the factors of variability are applied?
Gotcha. So this would be like you can do 80 or 90% of them.
Yeah, something like that. It depends on the exact problem, what will be the percentage, but it's a simplified pipeline, a simplified setup that is used to test the riskiest hypothesis.
So now we have all of that. Like, how does someone actually get to feeling comfortable with running it in a real system?
Usually it takes time, a lot of time and resources. I would say that you shouldn't plan for less than a year to implement a project for production. The next step usually would be running a pilot. So you get the real environment, you get the real production process. You narrow it down to some exact products or processes, not try to cover everything on the pilot. You check more hypotheses, you get more variability. And that's where usually a lot of projects get canceled. Because a great performance that you get on the proof of concept is not there, and the accuracy goes down when you go to pilots.
Right.
Because of variability.
This sounds a lot like the IoT kind of industry 4.0 digital transformation efforts, where it's like it gets pretty involved and you have to have a cultural shift to agree that this is like what we're trying to do, and it takes dedication, right? You have to iterate on this. Yeah, I get that. And also like you have to see what the results might be and tweak it. So yeah, okay, cool. So
I don't want to sound pessimistic. AI works and it's a great tool. It's that not everything works perfectly, and It's a more complex and more difficult and longer way than people usually expect.
Sure.
But when it works, it does work
Right.
pretty well. There is a real world which is very complex, and there is a simplification of this world, which is a model. You cannot come up with a model that is good enough to reflect all the variabilities in the real world. So you come to this process gradually, and you make the model more and more complex as you learn, and you implement it and you test it. And when it's complex enough and it's reflecting the variabilities that are the most important, then it's production ready.
Awesome. Cool. Well, now I want to do my AI project, so let's go.
Let's get on it.